Okay, so let's talk about async/await in Node.js. I mean, it completely changed the game for us JavaScript developers, right? It made our asynchronous code super clean, super readable. But what if that convenience comes with a hidden price tag, a cost that really only shows up when you start to scale? We're going to dive in and uncover a sneaky performance issue that might just be lurking in your own services right now.
So picture this. You've built this beautiful back-end service, all shiny and new, using modern async/wait. The code is elegant, all the tests are green, it's perfect. Then you push it to production, and, well, that's when the trouble starts. Real traffic hits, and suddenly everything just starts to bog down. Latency is creeping up, alerts are firing, and you're just staring at your screen wondering, the code looks totally fine, so why is everything on fire?
And so begins our investigation into this mysterious slowdown. This is a real head-scratcher. Your monitoring tools are telling you the CPU usage is through the roof. But when you actually profile your own code, there's nothing there. No crazy loops, no heavy math. Your application logic looks completely innocent. Okay, rule number one of backend troubleshooting, right? Blame the database first. It's almost always the database. A single slow query can bring even the most powerful system grinding to a halt. So, naturally, that's where we're going to look first. Let's check those query logs. And nope, not the database. The query logs are clean as a whistle. All the metrics say it's happy and healthy, performing exactly like it should. So we can cross our number one suspect right off the list. Well, the plot thickens. All right, fine. If it's not the database, what's next on the list? Has to be the network or some external dependency, right? Maybe a third-party API is being super slow. That can easily cause a huge bottleneck. Let's go check those external calls. And another dead end. Every single external service is responding just fine. No signs of any network trouble at all. We've now ruled out the two most common culprits. The problem isn't coming from outside our application, it's coming from inside the house. So this is the big question. If it's not our code, and it's not the database, and it's not the network, what on earth is eating all that CPU time? And this is where the profiling tools give us a really weird clue. The time isn't being spent in our code, but in the Node.js runtime itself. And that little clue brings us to the big reveal. It's time to unmask the hidden culprit behind all these performance problems. And you know what? It's something we use every single day, probably without ever giving it a second thought. And there it is. The profiler doesn't lie. Look at that massive slice of the pie. A huge chunk of our CPU time is being spent on something called promise and microtask management. Our actual application logic is that tiny little sliver over there. This just completely shatters the idea that async/await is a zero-cost abstraction. It's not free, it has a real runtime cost, and that cost becomes painfully obvious at scale. So here's what's actually happening under the hood. Every single time you write an async function, the JavaScript engine has to spin up a whole promise object just to manage it. And every single time you use await, it schedules a tiny little piece of work called a microtask. Now, for one or two requests, who cares? It's nothing. But when you're handling thousands of requests a second, all that tiny overhead starts to compound into a major performance killer. To really wrap our heads around this, we need to pop the hood and take a look at how the JavaScript engine is actually working. So let's dive a little deeper into the guts of Node.js and the V8 engine to see what's going on. This is the key concept right here. Async await. It feels like magic, but it's not. It's what we call syntactic sugar. It's just a nicer, cleaner way to write code that gets translated into something way more complex underneath. In this case, it becomes a promise-driven state machine. And the runtime, the JavaScript engine, has to actively manage that machine, pausing your code and resuming it later. And that management takes CPU cycles. So all those little continuations from our await calls, they get tossed into a special, super high priority line called the microtask queue. And here's the kicker. The event loop, which is the heart of Node.js, has to stop everything it's doing and completely empty this queue before it can move on to anything else, like, handling new incoming requests. So if that queue gets flooded with thousands of microtasks, you can see how it becomes a massive bottleneck. Now, I want to be clear, this isn't a bug. It's not a flaw in Node.js or V8. It's actually a very intentional engineering decision. It's a trade-off, a choice between two competing priorities, making life easy for developers versus raw, unadulterated performance.
And this really is the heart of it all. On the one hand, you've got async await, which is amazing for developer ergonomics and code readability. It just makes our lives so much easier. On the other hand, you have old school callbacks. Yeah, they can be a pain to work with. Callback hell, anyone? But they are incredibly fast because they add almost no overhead. It's a classic battle, convenience versus raw efficiency.
So does this mean you should just throw away async await and go back to writing callbacks for everything? No, absolutely not. For the vast majority of applications, the benefit of having clean, readable, maintainable code is way more important. This whole issue really only rears its ugly head in what we call hot paths, those critical, high-performance parts of your system that are handling insane amounts of traffic.
So what do we do about it? The key here isn't to abandon a fantastic tool like async await. It's about learning to use it wisely. We can strategically optimize these hot paths without having to rewrite our entire application from scratch. And here's your 4-step plan. First, you have to profile your system. You need to prove that this is actually your bottleneck. Don't guess. Second, once you've confirmed it, you identify those specific high-frequency hot paths. Third, you go in surgically and simplify the code just in those areas. Maybe that means you're moving an unnecessary async wrapper or flattening a chain of awaits. And finally, and this is crucial, you measure the impact to make sure your fix actually worked. And why should you even care about any of this? Because the consequences are very real. We're talking about higher latency for your users, which they hate. We're talking about higher CPU usage, which means bigger server bills for you. And maybe worst of all, hitting these unexpected scalability ceilings, where your app just can't handle any more traffic. This isn't just some academic exercise. It has a direct impact on your product and your budget. So we'll leave you with this final thought. Async await is just one example of a beautiful abstraction that feels like it's free, but it has a hidden cost. It's a great reminder to think a little more critically about the tools we reach for every single day. So the real question to ask yourself is, what other free abstractions are you paying for in your code?